Hello, welcome again. Today we are going to see what we call an indices. An indices in our day life also we used to have very large numbers which is very hard to read so that you can write it with different mistakes. So to avoid that we use what we call an index notations. We use different factors of the given number which is too large. For example, let's have an example of 16. For example, 16 is equal to 2 times 2 times 2 times 2, which is equal to 2. This is a base, it is 2 and different factors of 2, which is equal to 4 factors. So our factors is placed here, 2 power 4, which is equal to also 16. So here we have our power, which is equal to our index, and this is also a base. So this form, it is why it is called index notation. So we can't write 4 power 2 as our 16 also can be equal to 4 times 4, which is equal to 16. So this is not our index notation because 4 is not a prime number. Why? A prime number, it is a number which is greater than 1 and cannot be multiplied by two natural numbers, okay? For example, we have 2. 2, no other greater than 1 numbers that can multiply to get 2. Example, we have only 1 times 2, which is our 2 we have here, okay? So when you have 4, it will be equal to 2 times 2. This is not a prime numbers, okay? So our index notation, we can have also other examples. For example, let's take what we call 81. 81. 81 also you can have, it is 3 times 3 times 3 times 3, okay? Means we have 4 factors as it is 3 times 3 times 3 times 3, which is 4 factors of 81. So this will give 3 power 4, which is equal to 81. This is a base. This is our index. So this is also index notation of 81. So generally we can write n, which is equal to a power x. N is equal to a power x, so that our a is a base, then x is our index. So together a power x form index notation. So let's go to properties of index notation. Properties of index notation. When you have a power x, then times a power y when the base are the same. We take our a, which is our base, then we add our indexes or our powers, okay? Then take x plus y, okay? But when you have a power x divided by a power y, we will not add but we will subtract. Then we will take x, first of all a, which is our base, then power x, which is our first index, then minus y, which is our second index, okay? So that is the most important. So for example, let's take 2 power 5 then times 2 power 3. So we know that we have the same base. So when you have the same base, we will take our base, then power first index plus second index, which will give 2 power 7. But if it is division, for example, if you have 2 power 5 divided by 2 power 3, we will have 2 power 5 minus 2, 5 negative 2, which is all a powers, okay? So to get 2 power 2, okay? Yeah. Not only for real numbers, but also we can have fraction numbers, okay? Fraction numbers, for example, you can have 3 power 1 over 2, okay? Times 3 also power 1 over 2. Here, we will take 3 as our base, then power 1 over 2 plus 1 over 2, which will equal to 3 power 2 over 2, which is equal to 3 power 1. We can also have 3 power 1 over 2 divided by 3 power 1 over 2, which is equal to 3 power 1 over 2 negative 1 over 2, which is equal to 3 power 0, which is equal to 1. Okay, let's continue. So now let's see some simple equation that involve indices, okay? For example, you can have 2 power x. So this is what a simple equation that involve indices, okay? I said that we can have 2 power x, which is equal to 2 power 5. What do you understand here? When you have a power x is equal to, which is equal to a power y, for a power x, which is equal to a power y, here, you know, a is also equal to a, means base are equal. This means also x is equal to y, okay? So when we have here 2 power x is equal to 2 power 5, so this means that x is equal to 5, okay? In general, you can say that if a power x is equal to b power x, then a also is equal to b. Okay, let's take an example. Okay, 81 power n, it is equal to 3. Then what does it mean? 81 power n, it is equal to 3. Means we know that 81 is equal to, we are going to find if it can meet with this base. How then? So we know that 81 is equal to 3 power 4. Okay? So this will give us that 3 power 4, then power n is equal to 3 power 1, okay? Which will equal to 3 power 4n, which is equal to 3 power 1. Then, as you have seen within our properties, 4n is equal to 1. Then our n is equal to 1 over 4. Okay? This means our n is equal to 1 over 4. This is our sub-question A. Then for B, we have 9 power a negative 3 times 81 power 1 negative a, which is equal to 27 power negative a. Okay? So here, we know that this 9 is also, we can also find 9 by writing it as index notation, okay? As our index notation. 9 within our index notation, it is 3 power 2, okay? Then we add power a negative 3, okay? Times 81, we know that it is 3 power 4, okay? It is 3 power 4, then power 1 negative a, okay? Which is equal to 27. 27, it is 3 power 3, okay? 3 power 3, then power negative a, okay? So, we will find that 3 power 2 times a negative 3 times 3 power 4 times 1 negative a is equal to 3 power negative 3a. Okay? So here we will add our powers or our indices. Okay? So we will have 3 power 2a negative 6 plus 4 negative 4a, okay, which is equal to 3 power negative 3a. So here we will add our indices, which is equal to 3 power, we have here 2a, then negative 4a, which will remain as negative 2a, or negative 2a, then negative 6 plus 4, it is also equal to negative 2, equals negative 2, okay? So here we have negative 2a, negative 2, okay? Which is equal to a power negative 3a. No, 3 power negative 3a. So as the base are equal, we will equalize our indices, okay? So means negative 2a negative 2 is equal to negative 3 A, okay? So negative 2A plus 3A is equal to 2, okay? Means our A is equal to 2. That is our A, which is equal to 2.